Morning. I hope you tried these questions. Yes. And you were able to integrate all of them without any problems. The last one, what about the last one? Long. Is it? Did you convert both of them or just one of them? Maybe you should try just one of them. Odd numbers. Yeah, but even if it's odd numbers, you can just try cos squared. That might be easier. So let's look at that one, number 18. Number 18, we have the integral of cos cubed of 5x sine cubed of 5x dx. So what you can do is you can change the cos to cos squared times cos. So this is the integral cos squared 5x times cos 5x sine to the power of 3 of 5x dx. And then this one here is the one that you rewrite in terms of sine. So this is the integral 1 minus sine squared of 5x, and then we have cos 5x sine cubed 5x dx, and then multiply out the brackets. We have cos 5x sine cubed 5x dx, not dx, and then minus cos 5x sine to the power of 5 dx. And now you can just integrate it. So yes, it's cos and sine together. So this is sine to the power of 4 of 5x. You divide by 4 and then divide by 5 as well. So that's dividing by 20. And then here, sine, you have sine to the power, there's an x here. So you have sine to the power of 6 of x divided by, you divide by 6 and then by 5 as well. So that's dividing by 30. And then you add your constant of, this is 5x. So like that. Yeah.
Like if I divide both of them,
Yeah.
right? And then at the end, when I do everything, I have cos and sine the same thing. I can just differentiate, right?
Integrate. Yes.
Then even the other process is well.
Yeah, you said it was long, but it's up to you. There isn't just one specific way to do it, but I would advise in a test, if you have the short way or the long way, do it the short way. Then you know you will finish. Okay, so that's that one. I think the other ones are fine. Remember, as a general rule, try and convert to the one that is odd, especially if you have a product, one is odd, one is even. The one with the odd is the one that you should combine. You can try it with the even one. You may still get somewhere, but I think it will be much longer than if you were to convert the odd one. So then the next type of integrals we look at are integrals that look like this. So integrals of the form integral of tan to the power of n of x dx, and the integral of cot of n of x dx. So we look at powers of tan and powers of cot. Here we say that n is an integer. Okay, so with this one, we do something similar. We use our identities. We use that tan squared of x is equal to sec squared x minus 1. Because if I have sec squared minus 1, I have to integrate that. So that is easy to integrate because we know sec squared is the derivative of tan. And also that cot squared of x, this is cosec squared of x minus 1. So those are the two identities that we make use of. So let's look at the examples. The first one, we just integrate tan squared of x dx. Very simple. Rewrite tan squared as sec squared minus 1. So this is the integral of sec squared x minus 1 dx. Then the integral of sec squared is tan. So we have tan x minus x, and then you add your constant of integration. Okay, so that one pretty simple to do, nothing very difficult there. Okay, then number 2, we have the integral of tan cubed x dx. So we said we need to use the identity that tan squared is equal to sec squared minus 1. So we break this up to the integral of tan squared x times tan x dx. And then this tan squared, we rewrite it as sec squared minus 1. So this is the integral sec squared x minus 1 times tan x dx. Then multiply out the brackets. This is the integral of sec squared x tan x minus tan x dx. Okay, then the first one, we use the u substitution because we have tan and its derivative. So this is just tan squared x over 2. And then for the second one, to integrate tan, we would write it as sine over cos, and the derivative of sine is the cos that is on top. So that would be plus ln of cos. Let me just write that for the first one. So this is minus the integral of sine x over cos x dx. This is tan squared x over 2. And then here I can make this plus so that in the numerator I have minus sine x, which is the derivative of the denominator. So here it's like I'm integrating u prime over u, and that is just ln of u. So this is tan squared of x over 2 plus ln of cos x, and then you add your constant of integration. Number 3, integral of tan to the power of 4 of 2x dx. So again, we write this as tan squared times tan squared. So this is the integral of tan squared 2x times tan squared 2x dx. And then the tan squared 2x, we can, or one of them, we can rewrite it as sec squared 2x minus 1. So this is the integral of sec squared 2x minus 1, and then tan squared 2x dx. So we then multiply out our brackets and then see what we have. This is the integral of sec squared 2x tan squared 2x minus tan squared 2x dx. So with the first one, you can see this is u to the power of 2, and the derivative of u is sec squared. So if I integrate that, I would just have tan to the power of 3 divided by 3, and then you divide by the derivative of 2x, which is 6. Okay, so this is tan to the power of 3 of 2x. We divide by 3 and then by 2, which is the same as dividing by 6. And then tan squared of 2x, that one we have to again rewrite as sec squared minus 1. So we have minus the integral of sec squared 2x minus 1 dx. Okay, that's a dx. So we have tan to the power of 3 of 2x over 6, and then minus the integral of sec squared of 2x is just tan of 2x, and then we divide by 2. So this is tan of 2x divided by 2, and then the integral of minus 1 is minus x, but then we multiply with this negative here, so we get positive x plus our constant of integration. Okay, and number 4, the integral of cot squared of x dx. So cot squared, we must just write it as cosec squared minus 1. So this is the integral of cosec squared x minus 1 dx. And then these are just terms we can easily integrate. The integral of cosec squared is negative cot. So this is negative cot x, and then negative x plus c. Okay, that one fairly simple. And number 5, we have cot to the power of 3 of 3x dx. So here again, you want cot squared times cot, so that the cot squared you can rewrite in terms of cosec squared. So this is cot squared of 3x times a cot of 3x dx, and this is cosec squared of 3x minus 1 times cot of 3x dx. Then we can multiply out our brackets. This is the integral of cosec squared x, sec squared 3x, and then cot 3x minus cot 3x dx. Okay, so here we have the function and its derivative. So integrating, we just say minus cot cubed squared 3x. We divide by 2 and then divide by 3. So that means we are dividing by 6. And then the integral of cot, remember cot is cos over sine. So that is minus ln of sine x. 3x. Sine 3x. And then we have to divide by 3. Yeah. Okay. And then add your constant of integration like that. And then you are done. So this one with tan and cot, they seem fairly simple. There isn't very much to do there. So let's look at some of the questions in the exercise from 25 to 31. Let's see. So this is exercise 4.4. Let's start with number 25. What's number 25 say? So we have a definite integral here from 0 to pi over 4. And we're integrating tan squared of 3x dx. So integrating tan squared of 3x dx is pretty simple because we said all we need to do is convert this to sec squared minus 1. So this is the integral of sec squared 3x minus 1 dx. And then everything here is easy to integrate. This is the integral of sec squared 3x is tan 3x divided by 3. So that's tan 3x divided by 3. And then the integral of minus 1 is minus x. And we evaluate this from 0 to pi over 4. So this is tan of 3 pi over 4 divided by 3 minus pi over 4 and then minus 0, because when I substitute to 0 there, everything will be 0. So I can just write 0 there. Okay, tan of 3 pi over 4, what is that? Is it 1 or minus 1? 3 pi over 4 is in which quadrant? That's 45 times 3, 90. It's in the second quadrant, so it's negative. So I have negative 1 over 3. And then minus pi over 4. And then you can work that out on your calculator, whatever it is, that is your answer. Okay, number 6 is similar. We have the integral of cot squared x over 2 dx. So here we just need to rewrite cot squared as cosec squared minus 1. So this is the integral of cosec squared x over 2 minus 1 dx. And the integral of cosec squared is minus cot, and then we have to divide by half, so it's minus 2 cot x over 2 minus x plus our constant of integration. Okay, one more. 10 cubed of 2x dx, the integral of that. Okay, so this 10 squared times 10. So this is the integral of 10 squared 2x times 10 of 2x dx. Then 10 squared, we rewrite it as sec squared minus 1. So this is the integral of sec squared 2x minus 1 times 10 of 2x dx. Then this is sec squared 2x, 10 2x minus 10 2x dx. Then for the first one, we use a u substitution. We will have 10 to the power of 2 of 2x. We divide by 2 because of the power that goes up there, and then divide by 2 again because that is the derivative of what we have there. So now we are just dividing by we're just dividing by 4. Okay, here. Oh, okay, and this one is interesting because if it's sec squared 10, sec squared 10, you can also look at it as sec multiplied by sec 10. So you can say it's sec squared divided by 2 as well. So here, the way it's written here, this is the function and that is its derivative, but I could also write it as sec 2x times sec 2x tan 2x, and you can see that this is the derivative of that one. So you would follow the same procedure and get your derivative as sec squared 2x divided by 4 instead of 10 squared 2x here divided by 4, but both of them are fine. Okay, and then minus tan 2x. Remember, tan 2x is sine over cos, so we will get ln of, what's in the denominator, cos 2x, and then we must divide by the derivative of 2x. So this is plus. It's plus because in the numerator we need negative sign. So it's plus ln of half ln of cos 2x. And then you add your constant of integration. Okay. Okay, then number 28, 29, say to what? To 30. I'd like you guys to try those ones. See, 28, the integral of cot to the power of 3 of x dx. Pretty simple. 29, the integral of 10 to the power of 4 of x dx. Then 30, the integral of cot to the power of 5 of ax dx. And I think number 19 as well should be able to figure that out. Cos this 2x over squared. Substitution for the first term. See. Squared divided by 2 and it's minus squared divided by 2, but remember that e is cot, this is minus squared x over 2. So notes from last semester is just one number. Okay, this one here. When I get to set to the power of 4, it's the same as 10 to the power of 4. So that will not be helpful. What might be helpful is instead of writing it like this, I can write it as 10 squared times 10 squared and then change only one of the terms, because now integrating sec of 4 That is enough. When I differentiate this, I will get 1 over cos squared of x times 2 cos x sin x, which is not 10 squared. So the way you integrated this one is not correct. And it's not even ln. Make me shorter. This 10 squared was the very first example we did how to integrate it. We didn't write it like this. We just changed 10 squared to 6 squared minus 1. So only if it's just 10, then you can rewrite it as sine over cos. Constant. Here, we must unsubstitute. This one here, it might be better to write it as 10 squared times 10 squared and then change one of the 10 squareds.
So, right, okay.
Yeah. Instead of when you have sec to the power of 4, it's the same as 10 to the power of 4. How do you integrate that one? So, yeah. Here is to the power of 2, so the power must go up by 1. So to the power of 3 divided by 3. 2 divided by 2. This one is the first example that we did, the way we integrated it. This one, compare it to this one. When I see this converted like this, so I have 10 squared, I'll change it to 6 squared minus 1. Get 2 sec x times the derivative of sec x, which is sec x, and x and out. So we integrated that one is not correct. And this is what 2 over 2. This was the first, this was the first example we did.
cosec cot, you have, you can multiply with cosec. Yes, now you use new substitution. Here's the function to the power of 3, take its derivative. And the last term is just cot to the power of 3, which you is cot squared times cot. This is x squared over 2, and the power is 1, increases by 1, the power is already 2. So here it must be 3, that's fine. And here, that's fine. Okay, when we put this point here, we end up with cosec to the power of 4, which is not very helpful. So maybe, maybe just change this one and then multiply out the brackets and see what we get. How did you get but the derivative of cosec is cosec cot. So it's cot, cosec cot. So that the way is not correct. If you're saying you use cosec to the power of 4, no, just cosec x, the derivative will be cosec cot dx. But I only have cot. So that is not correct. What might be better is if we have cot squared dx, and then we cot of 3, then break out this one, and then multiply out the brackets. Then you get maybe 2 terms are simpler, and then one other term you can still take it down. Okay, for this one, here you can use a new substitution because the derivative of cot is this one. So instead of cosec squared, we take the cot. This is the wrong. Look at what we're doing. We're integrating tan and cot. Can we not change this to tan and cot? Yeah, but cosec is a derivative of cot. So if it's cot times cosec, I know how to work around that. So think of it in terms of what we're doing. We're talking about tan and cot. Just rewrite it. That might be useful. Are you okay now?
Yes.
Substitution. This one you must put down like.
Okay, so go and try those questions at home. Like I always say, practice, please, your attention. Practice is key. Number 19 and 20, they don't look like they fit in with these questions, but they are actually in line with what we are doing, because we're looking at tan and cot. Maybe what you should do with number 19 and 20, rewrite them in terms of tan and cot. And even if you have cosec there, you have cosec and cot multiplying. We've been working with questions like that. So you should be able to figure that one out. Okay, tomorrow we meet at 11:30. Are we supposed to be in G37 tomorrow? I'll see if the tech people can fix the projector. 57. Who is 57? Are you sure it's not 37? Yeah, okay, around here. I think the projectors around here are fine. But yeah, go and try them.